Welcome to the Level 1 video on Binomial Expansion and Taylor series. Today we're going to start off by talking about the binomial coefficient, okay, so let's recall a few statements about the binomial coefficient. So the binomial coefficients are the coefficients in the expansion of x plus 1 to the power of n. And the coefficient of x to the n in the expansion of x plus 1 to the n is denoted as n choose k, which is an n on top of a k with big brackets either side. And Pascal's triangle lists out all the binomial coefficients. And it does this in the following way. So in the 0th row we'd have 0, 0. In the first row we'd have 1 choose 0 and 1 choose 1. In the second row we would have 2 choose 0, 2 choose 1 and 2 choose 2. In the third row we would have 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, and so on and so on. And what does that actually translate to in terms of integers? 1, 1, 1, 1, 2, 1, 1, 3, 3, and 1, and so on and so on. And it's worth noting that Pascal's triangle is symmetric around the center point, so that n choose k is actually equal to n choose n minus k, and that each number, so if we take an integer here, say 3, then you can always generate that number by summing the two numbers above it. Okay, so if we took 2 here, then 2 would be the sum of the two numbers above it, 1 and 1. And we can also say that the second number in the nth row, so here we have 4 rows, the nth row, the first row, the second row, and the third row, and the second number in the nth row is always n. So moving on, let's talk about the binomial coefficient and how it's actually defined. So the binomial coefficient is given by n choose k is n factorial divided by n minus k factorial divided by k factorial. And in case you've forgotten, n factorial is n times n minus 1 times n minus 2 times everything in the middle times 3 times 2 times 1. Now let's move on and discuss the binomial theorem. So the binomial theorem is the following: a plus b to the power of n is the sum from k starting at 0 to n of n choose k multiplied by a to the power of n minus k and b to the k, and of course a and b here are interchangeable. And let's jump into an example. So using the binomial theorem, expand the following expression and the expression is 1 plus x to the power of 5. So our solution is that 1 plus x to the power of 5 is 5 choose 0, x to the 0, and all the powers of 1 here we're just going to leave, plus 5 choose 1, x to the 1, plus 5 choose 2, x to the 2, plus 5 choose 3, x cubed, plus 5 choose 4, x to the 4, plus 5 choose 5, x to the 5. And if we simplify these binomial coefficients, we get that 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4 plus x to the 5 is the expansion of 1 plus x to the power of 5. Thanks very much for listening.